Right, this is a difficult question, so let's listen to this. Now, the answer is as such, and the first thing that I will do is to figure out what is the resistance of this device. We know that to find resistance from an IV graph, there are actually two ways. I've always preferred the first way, to go back to the definition of resistance, where resistance is the ratio of the voltage to the current. So I will do that exactly. Resistance is a ratio of voltage to current. So this is my working. Resistance is at this point the voltage is 4, and at the same point the current is 16 ampere. All right, so there's a 10 to the power minus 3 here. So that's how we can get 250 ohm, and therefore the answer is either A or C. Now, to determine whether the answer is A or C, we have to look and predict whether the device is a thermistor or a filament. So to do this, there are a few ways. This is the IV profile of a thermistor. This is the IV profile of a filament. And you can memorize this. You can memorize this, but I always like to derive it out. Now, for a thermistor, as you increase the current, it heats up, and the resistance will decrease. This is very unlike what we have learned for a filament wire. A filament wire, according to kinetic model, as you heat up the wire with a lot of current, the resistance increases because the particles in the wire vibrate faster according to kinetic model, and this impedes the flow of current, therefore increasing the resistance. So this is a standard application of what we have learned. But for thermistor, the relationship is actually opposite, and you have to memorize this. I can share the reason behind, which is purely optional, but it would be interesting if you know it and you can appreciate this better. So I say again, do memorize these two statements, copy it down in your notes, it will be very helpful. And once you have this relationship known, you can then see that from this point to this point, the resistance have actually increased. And therefore, this confirms that this IV graph belongs to a filament wire. That's how you can get the answer. Pardon me in the missing out the 10 to the power minus 3, but even if you put in 10 to the power minus 3 here, you will see an increase in the resistance. So to get the answer to this question, either you memorize that the IV profile of a filament curves in this way, or you derive the resistance out, and after you calculated the resistance increases, you can determine that it's a filament. Now the optional stuff is on thermistor. Why does when current increases, shouldn't the wires, the thermistor should heat up, and shouldn't the thermistor particles vibrate faster like a filament wire, and shouldn't that increase resistance? Well, it does. The filament particles will vibrate faster. Kinetic model is still valid, but there's an additional effect happening. So the thermistor is like a superconductor, and when you heat up a thermistor, it has more energy, and this additional energy allows it to do something that is very different. It sort of releases the available electrons that can flow freely. So with this, there's more flow that can happen because now there's a lot more electrons that can flow more freely, and that's the reason why as thermistor heats up, even though on one hand the particles move faster and therefore it sort of blocks the electric current, on the other hand, an even more dominant effect is that when it heats up, a thermistor has now more electrons that can move, and therefore this reduces the resistance, it increases the flow of electric current. So this is something on superconductor theory. Google for it if you want, or you can just have a chat with me. And one more extra thing to share with everyone. In O-level, whenever you see a thermistor, we always take this relationship to be true. and that is the thermistor resistance will decrease when temperature increases, when the current increases, like what I've written over here. So this is by default, and I just want you to know that the reverse might happen also. This default behavior belongs to a type of thermistor called NTC, and NTC stands for negative temperature coefficient. It's just a type of thermistor, and by default, this is the thermistors that we are talking about in O level. So memorize this point over here, but just know that in reality, this is just one type of thermistor. There is another type of thermistors where as you increase the temperature, as you increase the current, the resistance will increase. All right, so we call that PTC, positive temperature coefficient thermistor. So all that I shared here is just optional and for your info. What you need to know is this line over here and this line over here. These two you must know.